All right, ladies and gentlemen, welcome to today's class. And what we're going to be doing today is we're going to be talking about angles and standard position. So let me get this real quick so we can start sharing the whiteboard. So today we're actually starting on the first section of the next chapter. And we're going to talk a little bit of review a little bit about what angles are. And we know that angles basically have what we call a terminal side and an initial side. So we're going to see angles, but we're going to see them on the x or the coordinate plane or the x or y axes. And an angle usually starts from the positive side and then kind of moves along. So give me 1 second while I get the pages and we can get ourselves acclimated here to get started. Um, Here we go. So these are the pages. This. So let's talk real quick about angles. And I want to illustrate to you guys the terminal side and or the initial side and the terminal side. So an angle in standard position, um, if its initial side um, along with the positive x-axis and its vertical side is at the origin. So once again, an angle is said to be in standard position if its initial side is along the positive x-axis and its vertex is at the origin. So basically, if we have an angle, we know that this is the initial side. So if it's in standard form, it means that the initial side of the angle starts in the x-axis, the positive x-axis to be exact, and its vertex, which is right here, is at its origin. And of course, we have the terminal side in this case, which is here. So think about angles kind of like a clock, so to speak. You have the short hand, which stays in the hour, and the minute hand, which moves. So this is the initial side right here. Initial side. I'm just going to go right ahead and write initial. And this is the terminal side right here. So this is the terminal side. And the vertex is right here. It's basically where they meet up. So this is the vertex, and of course the origin, which we know is 0, 0. So an angle is in standard form if the vertex, if the initial side is in the positive x-axis and the vertex is at the origin, which we all know is 0, 0. Okay, so today we're going to see how to graph angles in standard form, and also we're going to see how to determine if a pair of angles are coterminal to each other or not. So let's just look at it at one step at a time. All right, guys. Um, Excuse me. It says the terminal side and the initial side. Again, I read the definition, or I'm going to read this. It says, and of course, the angles are located in quadrants. Okay, so let me actually draw another coordinate plane here, illustrating the quadrants. Now, when you've been working with the coordinate or you've been working with the x and y access pretty much all of your mathematical or middle school and high school tenure. Excuse me for a second, guys. So we have, pardon me for that. This is quadrant 1 right here. This is quadrant 2. This is quadrant 3. And this right here is quadrant 4. Okay. So when we talk about angle rotations, we're going to see that the quadrants, especially when we're talking about standard forms or angles in standard form, is very important to understand. Now, if I look at quadrant 1, basically in quadrant 1, I'm going to have angles that are from 0 to 90. So we would say in quadrant 1, Z or V or phi is greater than 0, but less than 90. And what that is telling us or indicating is that basically in the first quadrant, you're going to find any angle from 0 degrees all the way up to 90 degrees. You're not going to see anything above 90 in quadrant 1. When you go to quadrant 2, you're basically going to find angles where Z is going to be greater than 90, greater than 90, but less than 180. Notice how they're not less than or equal to or greater than or equal to. That means that if an angle is on 180, it's not in a quadrant per se, it's just on an axis. Okay. So in quadrant 2, you'll find angles that are greater than 90 but smaller than 180. Quadrant 3, you'll find angles or Z. Give me 1 second. Basically, Z is going to be a number greater than 180, greater than 180, but less than 270. So basically angles that go from about 180 to 270 degrees. Okay, that would be in quadrant 3. And in quadrant 4, you would have or Z would be greater than 270, greater than 270, but less than 360. 360. Okay. So before we start graphing our terminals and before we start graphing our angles in standard form or determining if there are ordered pairs and if an angle is in standard form or not, I want to go over something that's very basic, especially when we're working with angles, to understand, besides the fact that this is the initial side and this is the terminal side, and that would be the rotation. Okay, so if an angle rotates counterclockwise, and I'm just drawing that arrow to indicate the direction. So counterclockwise, or CW, counterclockwise, we have a positive rotation. Okay, and that's always good to understand. If we go counterclockwise, we have a positive rotation. And if we go clockwise, counterclockwise, or CW, we have a negative rotation. Okay, so negative rotation. Now, good to understand this, especially now that we're going to look at example number 1 real quick. So I'm actually going to go ahead and erase this. If you have any doubts with any of the theory or the concepts, you can always go back and pause the video. I am going to leave the quadrants, the coordinate plane, talking about explaining the quadrant concepts, because they're gonna be useful to us in example number 1, at least, so we can kind of have a visual aid of what we're doing. All right. So example number 1 for this section is actually on page. And let me fix this. Example number 1 is, if I'm not mistaken, on page 68, I believe. Could be mistaken. Anyway, example number 1 says, sketch the following angles in standard position. So let me go ahead and write it here. Example number 1 says, I think I can write it down here. Sketch each angle in standard position sketch each angle in standard position and state the quadrant or axis on which the terminal side lies, or axis on which the terminal side lies. Okay, let's see if I can move that here. Yeah, there you go. Perfect. So example number 1 says, sketch each angle in standard position and state the quadrant or axis on which the terminal side lies. Now, the two angles that are given to us in example 1 are negative 90 and 210 degrees. So let me write that down. So A is negative 90 degrees. And B is 210 degrees, okay? Now, important, very important that you understand this. The rotations of the angles, especially when we are trying to graph them in standard position. So, in standard position, the definition says that the initial side must be on the positive. So let's do A. Let's do 90. So here's my vertex, or here's my origin, right? And it says that the vertex must be in the origin. So I know I'm going to start here with my my initial side. Now, it's negative 90. Remember what I said. I said, if the rotation is counterclockwise, and let me use yellow. If it's counterclockwise, that moves this way, the rotation is positive. And if it's clockwise, like this, that means that the rotation is negative. So this is a positive rotation again, and this is a negative one. If we have negative 90, then that means that the rotation is not going this way counterclockwise, but rather clockwise. So that means that the angle, the terminal side of the angle, would actually be down here. So if it's in standard position, here is where my terminal side would be. Okay, let me erase this. So the terminal side would be here. So this is where my terminal side would be. Terminal side. And give me 1 second. Where does it lie? It actually lies on the x-axis. So the terminal side lies on the x-axis. Okay. Let's see if I can move that a little bit further here. Okay. You know what? Let's just move it down. Let's move it down here. So the terminal side lies on the x-axis. So the terminal side lies on the x-axis. All right, and that's example 1a. The terminal side lies on the x-axis, and the reason is because it is a clockwise rotation, which means that that is a negative rotation. Okay, so that's where the terminal side would be, and it lies. I'm sorry, I realized I made a mistake. Give me 1 second. Not on the x-axis. The terminal side lies on the y-axis. Let me fix that. The terminal side lays on the negative y-axis because it's negative. Again, standard position, guys. Standard position means that the initial side, which is this one, is on the positive x-axis. But in the case of negative 90, because it's a clockwise rotation and has a negative rotation, the terminal side actually lies on the negative y-axis. So that's example A. Example A is pretty easy. Now let's look at example 1B. Example 1B. Is asking us to graph positive 210 degrees. Now, I didn't erase my initial side because if it's in standard position, the initial side will always start on the positive x-axis. Now, 210 would lie in which quadrant? Well, we know that in quadrant 1, basically angles are from 0 to 90. In quadrant 2, basically they're from 90 to 180. And then in quadrant 3, they're pretty much from 180 to 270. So I know that the terminal side is going to be in quadrant 3. So this is where 280 is. This is where 180 is. So 210 would be about 30 more. So we'll say that it's more or less about here. This is where the terminal side would be. And remember, I'm moving counterclockwise. So remember that counterclockwise means positive rotation. So moving counterclockwise. And it lies, the terminal side, which is right here, lies on quadrant 3. So that's pretty much it. So the terminal side, let me go ahead and text that here in the box. Terminal side lies on quadrant Okay, wait, one more. So the terminal side lies on quadrant 3. Okay. Now let's look real quick at what a coterminal angle is. So I'm actually gonna look for the pages here. Give me one sec, ladies and gentlemen, so I can acclimate and find the pages. And let's define what a coterminal angle is according to your textbook. So basically, a coterminal angle is, or a coterminal angle says two angles in standard position with the same terminal side are called coterminal. So let me erase some things here so we can go on and move on to the next example. So coterminal angles, and again, first of all, have to be in standard position, meaning that the initial side has to be on the positive x-axis, okay? And two angles are coterminal if they actually have the terminal side located on the same quadrant. So again, I read the definition. It says two angles in standard position with the same terminal sides are called coterminal. So for example, if two angles have the same terminal side, or the terminal side lies on the same exact place, they are considered to be coterminal. So let's go to example number 2. And example number 2 says determine whether the following angles are coterminal, where the following pairs of angles, the following pairs of angles are coterminal. So in other words, that the pairs of angles actually have the same terminal side, or that the terminal side is located in the same position. So let me erase this down here real quick. Okay. So the angles that are given to us in this exercise are you have two pairs of angle. You have um, alpha and beta. So alpha is 120 degrees. Alpha is 120 degrees. And beta is negative 180. Now I want to know if they are coterminal. In other words, I want to know if the terminal side of each angle, assuming they're in standard position, is the same. Now, it's good to understand that there are an infinite amount of coterminal angles. It's not like when we were working with 30, 60, and 45, where they had the same cosine or the same tangent, and that never changed. In the case of terminal angles, they are infinite. So that means I can have um, an infinite amount of coterminal angles. So let's first graph 120. So in standard position, that means that the initial side starts here in the x-axis, the positive x-axis. And then let's see where that goes. So first of all, it's positive 120, which means that the rotation is counterclockwise. And of course, it has to lie on quadrant 2, because quadrant 2 says that that's where I can find angles that are greater than 90 and less than 180. So basically, this is where the terminal side, actually, I think it's a little bit lower. Let me see if I can delete that. Okay, so it's actually, let's see, more or less where that angle is drawn. Actually, it was kind of like here. So 90 is here, 120 would be about here, more or less. So this would be the terminal side. Now, in order for these two angles to be considered coterminal, that means that the terminal side of negative 180 has to be here as well. So let's use blue to illustrate 180. So basically, and I'm just going to kind of shades of blue because they're in standard form. So that means that they have to be in the same initial position. So the negative 180 has to be also, has to also start in the positive x-axis because they are uh, in standard position. Now, the difference lies in where the terminal side would be. So negative 180 indicates that there is in fact a positive rotation. I mean a negative rotation. So that means that it's moving clockwise. So that means that our 120 moved counterclockwise. It moved this way, and that's why there's a positive rotation. 180 actually, or negative 180 actually moves counterclockwise. So again, that means that it moves in this direction. So if I realize, so now it's basically the opposite. This is negative 90 down. If whenever I have a clockwise rotation right down here, this right here would be negative 90. This would be negative 180. This would be negative 270. And basically this would be 360. Okay. So let me go ahead and erase that for you guys so we can get to what we were doing. So that means that, well, the negative 180 would be, or the terminal side of this negative 180 degree angle would be more or less, excuse me, um, here. It's a straight angle. So it would actually go this way. And if you notice, it's a straight angle. And that means that it's 180 degrees, but it's negative. The terminal side of this angle is negative. So that means that they are not coterminal because, and what makes them not coterminal is the fact that in 120, here's where my terminal side is located. And in negative 180, here's where my terminal side is located. Notice how they're not in the same position. Had this terminal side, the one in blue, shaded in blue for the 180, had it finished somewhere else and they would have had the same coterminal side or terminal side, then that would be coterminal. But since 120, the terminal side of 120 is here and the terminal side of negative 180 is here, they are not coterminal angles. So we simply indicate them as not coterminal angles, not coterminal angles. Okay. Now we're going to look at B. So let me go ahead and erase this real quick. Let's look at B. I'm always going to leave the terminal side written. And the reason I do that is because we're assuming that the angles are in standard position. And if they are in standard position, then that just means that they are going to start at the positive x-axis. So the other pair of angle that I have, for example, 2b specifically, is, and I seem to have lost it. No, here we are. I believe is 20 degrees and 740. So alpha now is going to be 20 degrees. Let me erase this so that we don't get confused. So alpha right here is going to be 120 degrees. And beta is actually going to equal 740 degrees. Now, let's understand one thing. In a rotation, whether clockwise or counterclockwise, a full rotation is 360 degrees. So we have 740, and obviously that means that it's that the angle rotates more than once. But let's work with the alpha first. So alpha is 20 degrees, and we know that it's positive, so there's a counterclockwise rotation, and the since they're assumed to be in standard form, the initial side is on the positive x-axis, and 20 degrees is actually in quadrant 1 because it's between 0 and 90. So more or less about here is where the terminal side of that angle should be. Now, let's look at 740 degrees. So we're assuming that it's in standard position. So basically, it's going to start in the same position, the positive x-axis, but it's more than one rotation. Now, because it's positive, we assume that the rotation is counterclockwise. So there's one full rotation, and basically one full rotation here is 360 degrees, but it's 740. So there's actually another full rotation. So we have two full rotations because 360 plus 360 is 720. So there's another full rotation, and that's 720. And I'm still missing 20 degrees. So from the two full rotations, which is 720 degrees, I actually go 20 degrees more. So because two full rotations is 720, so then I actually go 20 degrees more, and it's actually right here. So in reality, 720 and 20 degrees are coterminal because both of their terminal sides end in the same place. So in this case, this is 740 degrees and 20 degrees are coterminal. All right, ladies and gentlemen. So that's it for this video, angles in standard form. Hopefully this will be of good use to you guys. So stay safe, and we will see each other in our next class. All right. So do yourselves a favor and have an awesome day. Bye.